Let's look at how the distribution of electrons in covalent bonds leads to polarity and sometimes to dipole moments in molecules. You might already know that when both atoms of a bond are identical, as in this hydrogen molecule, the bonding electrons are shared equally between the two atoms. This is a pure covalent bond. There is no polarity or dipole in diatomic hydrogen. When the bonding atoms are not identical, as in hydrogen fluoride, the electrons are distributed unequally. The fluorine atom, with a higher electronegativity value than the hydrogen atom, has a partial negative charge, while the hydrogen atom has a partial positive charge. Since the fluorine-hydrogen bond has negative and positive poles, we call it a polar covalent bond. Hydrogen fluoride is a polar molecule because it has a difference in charge from one end to the other. Let's see how polar bonds lead to a dipole moment. Molecules that have a net difference in polarity from one end to the other are said to have a dipole moment. The dipole moment of a molecule is a measure of the degree of separation of charge in a polar molecule. A dipole moment indicates how polar a polar molecule is. The dipole moment of a polar molecule has both direction and magnitude. A molecule's dipole, symbolized by the Greek letter mu, is indicated with an arrow that follows the direction of increasing negative charge.